3, 15, 17. The Ides of March today. This is when Caesar was assassinated by Brutus and all his cronies. Yeah, it's true. The Ides of March. The Ides of March are March 15th. Way back in Roman times, Augustus Caesar, no, it was Julius Caesar, sorry, Julius Caesar was a tyrant. Yeah, he was like a dictator. He considered himself a god. I mean, he really thought he was a god. And his friends didn't think so. So he woke up, I know I'm on film, but he woke up in the morning and a terrible thing happened. A bird was in his room, and this is part of their superstition. The bird flew through his bedroom from left to right and flew out of his window. Now, in those days, that was a bad omen. Something bad was going to happen. Sure enough, he got to the Capitol, and there on the steps, his best friend stabbed him, and then all the rest of the Capitol cabinet stabbed and killed him and threw him down the stairs, and they killed his wife and his children. It was a bad day. So they always say, beware of the Ides of March, which is March 15th. You guys just learned something, didn't you? Did anybody know that? There's a few of you that knew that. Was he 23 times? Wow, see, there you go. Even more information.
I don't think he ever became a dictator. That was because he was going to become one.
Right. And of course, back in those days, if you were, Caesar, the term Caesar means kind of God, right? Okay, so anyway, back to this. Let's solve. One of the things I always do is I continuously put this on your notes. You notice that? It's on there every single time because quite often we're going to convert from log forms to exponential form, okay? Common Core, F for function. IF for interpreting function, E. It says using logarithms to solve exponential equations. All right? So if we take a look at example 1a, one of the things I need to do, somehow we need to get this 2x to come down. Because you can't solve for x while it's in the exponent. So the way you float it down is by taking the log of both sides. So if you take the log of both sides, if I go log of 5 to the 2x is equal to log of 125, then what happens is that 2x will float down. Okay, if you take the log of both sides. So you take the log of both sides, The whole reason of doing this is when you take the log of both sides, you can apply the exponent rule, which brings this down. Okay, then I have 2x times the log of 5 equals the log of 125. Now, log of 5 is just a number in your calculator. It is just a number. So if you have 2x times that, we're going to undo it by dividing by the log of 5. Okay, so we'll divide by the log of 5, divide by the log of 5. So just divide by log of 5, divide by log 5, and this cancels. Now, I'm going to need my calculator, okay? So I'll have 2x, I'm running out of room, so I'll slide it over here. I'll have 2x equals, so I'll use my calculator. What is, okay, Marie, help me stay square on this one. So I'm going to take and go log of 125, close the parentheses, close the parentheses, because you want log of 125 and nothing more, divided by log of 5. You need to close your parentheses, otherwise you will get a different value, okay? Enter, and you get 3, okay? So you get really 2x equals 3, divide by 2, and x is equal to 3/2, okay? So, key to this whole thing, Taylor, is really, if you take the log of both sides, if you have x in the exponent, okay, you have to take the logarithm to get it down. Does that make sense? Okay, how about b? Same thing with b. You need the x plus 2 to come down. Okay, thank you, Marie. You need the x plus 2 to come down. So we take the log of both sides, log of 3 to the x plus 2 equals log of 7. Okay, you have to take the log of both sides to bring it down. So then x plus 2 comes down. So I got in parentheses x plus 2 times log of 3 equals log of 7, right? Log of 3 is just a number in your calculator, so I'm going to divide. Divide log of 3, divide by log 3, divide by log 3, and I've got x plus 2 equals whatever this is. And I just use my calculator to figure out what that is. Okay, so let's go clear. I'm just going to do my log 7, close the parentheses, divided by log 3, close parentheses, and I get about a 1.77. And then I just go minus 2, right? And I get an answer of a negative 0.228 approximately, okay? Not too bad, right? So the trick is, if you have a variable in your exponent, when you take the log of it, it brings it down, okay? That's a really easy little rule to remember, okay? All right? C, all right? Divide by 8 first. Does that make sense? Divide by 8 first. What is 20 divided by 8? I don't know. 20 divided by 8, 2.5, right? So I have e to the 2x equals 2.5. Now, there are two ways to do this one, okay? I'm going to use the natural log because I know this. Little side note, write this down. Little side note, ln of e is equal to 1. Okay, ln of e is equal to 1. In fact, you can try it at a calculator if you don't believe me. ln of e is 1, okay? So ln of e is 1. I'm going to use that information to do this problem. So you could take the log of both sides, but we have natural log, which is also log. So I'm going to take the natural log of e equals the natural log of 2.5. So natural log of e to the 2.5, and I'm going to skip a step, okay? I'm going to float this down right off the bat, okay? Do you mind if I skip a step? Because it floated it down, right? So the reason you take the log of both sides, it floats it down. I like the natural log of e because this is 1. ln of e is 1, so I'm going to cross it out. I don't need a calculator. ln of e is 1, okay? So 2x times 1 is just 2x, right? So then I have a 2x equals ln of 2.5. Solve for x, just divide by 2, divide by 2. Now I will need a calculator to get a value, so I'm going to go ahead and just do ln of 2.5. So I'm just going to take my natural log of 2.5, close the parentheses, divided by 2 is about 0.458. 0.458, okay? Not too bad. So it really does come back to the one trick, and that is if when you want to get the x out of the exponent, take the log of both sides, okay? Now, D's a little bit harder to do, okay? Now, to do D, little side note again, okay? E to the x, am I off? Here we go. Thank you. E to the x times e to the x, okay? When you multiply like bases, you add exponents, don't you? So it's the same thing as e to the 2x. E to the x times e to the x is e to the 2x. Because when you multiply like bases, you add the exponents, right? So what I'm going to do is take a look at D, and knowing that, I'm going to take a look at D, and I'm going to factor. But instead of x and x, it's going to be e and e. I'm going to have an e to the x, e to the x. I'm going to have a negative 3 and a positive 2. Okay? Real quickly, let's do a little FOIL to check this, okay? So a little FOIL on the side. Okay, this times this is e to the 2x, okay? This times this is a positive 2e to the x. This times this is a minus 3e to the x, and this times it's a minus 6, which does make the original problem. You guys agree with that?
Yep.
Okay, so now, oh boy, we're in pre-calc now, aren't we? All right, now I'm making you really think. That's good. So now, I have two equations. Let's set them both equal to 0. E to the x minus 3 equals 0, and e to the x plus 2 equals 0, okay? Bring over the 3. E to the x equals 3. Bring over the 2. E to the x equals negative 2, okay? Now what? What's x equal? Well, in this case, x is equal to the natural log of 3. Ooh, how did I go from there to there? Well, I just changed it from log form to exponential form, right? No, actually, I went the other way around. Exponential form to log form, right? I went from exponential form to log form. The only difference is this is a natural log, right? Okay, and then I can take natural log of 3, right? I could leave that answer, but what is the natural log of 3? ln3 is about 1.09, approximately 1.0, maybe 99. And in this case, I'll take the ln of negative 2, okay? Except it won't work. In fact, let's give it a try. ln negative 2. It doesn't like that. So you cannot, little note, you cannot, we'll put up here, okay, way up here, give us a little note, you can not, yeah, take the log of a negative number. Can't. It won't work because no matter what exponent you have, you'll never get a negative number. You can get a smaller and smaller and smaller number, but you can never get a negative number, okay? All right, slide it back up. Let's do E. Okay, now, when I look at E, I see an x and an x squared. I say an e to the x also. So I'm going to common factor. It seems like what they have in common is an x and an e to the x. That's what I see. So if I common factor out an x e to the x, what's left over would be a 3 plus an x, right? So then I'm going to have 3 different possible answers. I'm going to have x equals 0, e to the x equals 0, and 3 plus x equals 0. Okay, so I got 3 parts. I'm going to have 3 different answers, okay? X equals 0, boom, that one's done. I totally agree with that answer because if x is 0, it does turn out to be 0, okay? E to the x equals 0. So if I take the natural log of 0, I'll get x, right? Well, try it. What's the natural log of 0? Anybody have a calculator handy? What's the natural log of 0? Yeah, because you can't. Yeah, because you take e to any power, you'll never get 0. So throw that one out. And then you get x equals negative 3, which that should work, okay? So you really only get 2 answers. Well, these are fun, aren't they? I like these. Okay, return the page. I can, Zane. How's that? You got it? Okay, return the page. Give me a thumbs up when you're ready. Thumbs up, okay. On the back side. Hey, now these are log equations, all right? Now the trick to doing log equations is to try and make them into exponential. So what we want to do is we want to eventually change to exponential form, okay? So up on the board again, if we've got log form to exponential form, we're going to try and eventually shift from log form to exponential form, okay? So right off the bat, I'm going to go, and I want everybody to watch. It's easy. 2 to the third power equals what's inside. I'll say it again. 2 to the third power equals what's inside. That's how you change it to exponential form. So I go 2 to the third equals 25 minus x. I am only using this rule, log form, and I change it to exponential form. See how it works? I went from here. That's my 2 to the third power equals what inside. See what I did? 2 to the third equals what's inside. Okay. So now it's pretty easy to solve. 2 thirds, not 6. It is not 6. It's 8. 25 minus x, right? Subtract 25, and I get a negative 17 equals a negative x, right? Get rid of the negative, and x is equal to 17. How is that? Capiche? Okay. All right. How about B? What do you think about B? Well, let's get rid of this 4 first. It's kind of annoying. Let's just subtract out the 4. Okay, subtract 4, cancels out, gone. So to have a 3 log of 2x equals 12. Okay, how's that? Let's get rid of this 3. That's kind of annoying too, huh? Divide by 3, divide by 3. I've got log of 2x equals 4. Now I need to change it to exponential form, but I've got a small problem, but we're all pretty smart. We know what the problem is. It doesn't have a base.
10.
Yeah, you guys agree? Base 10. It's got a base. So let's go 10 to the 4th power equals 2x. We're going to go 10 to the 4th power equals 2x. And that's how it works. We're going to go 10 to the 4th power equals 2x. 10 to the 4th power is 10,000. Divide by 2, and I think it's 5,000 equals x, okay? Okay, C and D, here comes my favorites. I like these. We're going to get to FOIL and factor and all sorts of good stuff on this one. I like C. C's great. Okay, now, how do I combine these logs? Let's go back to yesterday's notes. Yes. If it's add, we can bring them together. It's multiply, okay? Yesterday's notes said we can go log of x plus 2 times x equals log of 8, okay? Now, there are two ways to do this. We're going to do it the easy way. Log of this equals log of this, and obviously this must equal the 8. Does that make sense? The mathematical way is we just change them both to exponential form, but it's so much easier to say log of this, so whatever's in here has to be equal to 8, right? So we'll just cross out the logs. That's absolutely unmathematical, but that's exactly what happens. If you've got log of this equals log of this, cancel the logs, okay? So then you really get an x times an x plus 2 equals 8. Oh man, it looks like a little bit of algebra. X squared plus 2x equals 8. I think we're going to have to do the F word again. Looks like an F word. Factor. Bring over the 8. X squared plus 2x minus 8 equals 0, right? Factor. What do you think? Yep. How about a positive 4, negative 2, right? I agree. But of course it has to equal the opposites, right? Because we're solving for it. So x would equal negative 4 and x is equal to 2, right? Almost.
Oh, negative 4, you can have a negative number.
Because you put negative 4 right in there. You put negative 4 right in here. Oh, negative 4 right into there. You're going to have trouble, okay? So you throw out the negative 4. Good job, Marie. All right, last one, okay? Now, what we're going to have to do is combine these, okay? So let's do what we just did, okay? We're going to combine them. If it's plus, we can bring them together as multiply, right? So I'm going to go log of x plus 2 times x minus 1 equals 1, okay? Now, I can't get rid of the log. I can't go log, cancel. I can't cancel logs. But what I can do is change this to exponential form. Okay, I'm going to go 10 to the 1 equals what's inside. 10 to the 1 equals what's inside. So I'm going to go, all right, 10 to the 1 power equals x plus 2 times x minus 1, okay? Well, 10 to the 1 is 10, right? And I'll do a little FOIL, another F word. This math is just full of F words, huh? X squared minus 1x plus a 2x minus a 2, right? Ten is equal to an x squared plus a 1x minus 2, right? Because I just combine my x's. Let's bring over the 10. Let's subtract the 10. Minus 10 minus 10. So 0 equals x squared plus 1x minus 12. And we can factor. Factor. What do you think? X plus 4, x minus 3. You guys okay with that? But of course it's just equal to the opposite because you have to solve for it, right? So x will equal negative 4, not, and x equals 3, right? We're going to throw out the negative 4. You guys agree with that? Guys, if you plug the negative 4 back in, you're going to get negative values, so throw that away, okay? All right, so it's a lot of little problems. I selected the ones I wanted, so it is 368, 36, 11, 13, 19, 28, 38, 49, 63, 65, and 94.